All right, for the first lesson in Unit 2, we are going to discuss properties of radicals. So your goal today is to learn how to simplify radicals, like I did in that quick video before this, and also to apply a couple properties of radicals. So we're going to start with multiplication and division properties. So this is basically allowing or telling you what you are allowed to do with multiplication that is happening within two radicals. I'm going to give you an example of what this might look like. Let's say that we're looking at something like the cube root of 10. So the multiplication property simply says that if you can rewrite the number that you have as a product, like 10 is equivalent to 5 times 2, then you are allowed to break up the radical by putting each number in its own individual, that's supposed to be a 3, in its own individual radical with a multiplication sign in between. Okay, so we're allowed to break up a radical like this. But the converse is also true. So you could look at this backwards. Here's what I mean. So if I have two radicals that are being multiplied together, like so, by the multiplication property, I am allowed to put those two things into the same radical so long as they have the same type of root. So this is both a square root. There's no 2 for square roots written, but they both mean square root. So I could put them into one square root symbol, and I can simplify that way. So 3 times 12 is 36, and then that time I could even say square root of 36 is equal to 6. We also have properties for division that work in a similar manner. So let's say I have a division problem inside of a radical like this. I am allowed to break it up and put that radical over top of the numerator and the denominator separately. And then you can simplify if possible. So like square root of 36 is equal to 6. Square root of 4 is equal to 2, so this whole thing ends up equaling 3. I can also do the same thing in reverse. So if I were to have a square root of 36 and a square root of 4 written like this, I am allowed to also turn it back into one big radical, considering that they both are the same kind of radical. So both square roots or both cube roots or what have you. So here's how that would work. I could put it back into a fraction all in one big radical sign, and then I could divide the numbers inside the fraction, and 36 divided by 4 is 9, right? And then I could simplify from there and say square root of 9 is equal to 3. So we're going to look at some examples of simplifying radicals and a couple of examples of using these properties. Here we go. So the first one is just a review again of the examples I did in the first introductory video. So I'm looking for what times what equals 98. 2 times 49 I know works. And I'm going to continue breaking this down until I get to prime numbers. Now this is a square root, so I'm looking for 2 matching numbers, which I do have. And because I have a matching set, that means I can take that number outside of the radical, and anything that doesn't have a match will go back inside of the radical. So 7 radical 2 would be the correct simplification for that problem. Let's go to the next one. Now the next one is a multiplication problem. So we're going to use the property, multiplication property, that allows us to combine these two radicals. And I'm allowed to combine because they're both cube roots. So I can put 25 and 10 into one big radical like this and multiply those two values together, which would be 250. Now this answer is not correct. It's not completely done because I do still need to simplify the radical. It's kind of like simplifying a fraction. So we're going to keep going, and we're going to break down our radical, making a little factor tree. And this is a cube root, so I'm looking for 3 things that match. And I do have 3 5s. So because I have 3 like numbers, I'm going to bring that number to the outside. And then I'm going to leave anything that's left, in this case just a 2, inside of the radical. So final answer is 5 cube root of 2. Okay, so let's look at example C. This one's a fraction, so we're going to use that division property that allows us to take the numerator and the denominator and put them into their own radical, like so. And then you can simplify the numerator and the denominator separately, which the way that this is set up, I need to kind of go over to the side and do my little factor trees to figure out what these things are going to simplify to. So for 81, this is what my factor tree would look like. I'm doing a cube root, so I need 3 of the same number. And I have 3 3s, so I can bring the 3 to the front. And I have 1 left over that doesn't have a set of 3 to go with it. So cube root of 81 is equal to 3 cube root of 3. So I'm going to put that on the top. And then the cube root of 8, I need 3 of the same thing. I actually have exactly 3 of the same thing. So my answer for that is just 2. And so this would be my final answer is 3 cube root of 3 all divided by 2. Goodness sake, that was horrible. Let's try that again. There we go. Oh, that's a little better. Okay, good enough. All right, last one here. So we're going to, again, use the division property. I do want to point out one thing. I could just go over here and try to do a factor tree for 60 and, figure out 5 like I did on the last example. I want to show you why applying the division property would likely be easier in this case. It's going to be easier in this case because if I put these into one radical sign, 60 divided by 5 does divide evenly. So if you see numbers that divide evenly, maybe go ahead and put them back into a fraction together and divide them and then do the rest. So I still do need to do a factor tree to simplify radical 12, but it's a lot faster to do this versus figuring out what 60 equals and then 5 and then going from there. Anyway, I'm doing a square root, so I need a match of 2 things, and anything that's left over goes in the radical. In this case, that is a 3. So 2 radical 3 would be the answer here. So we have a property for multiplication, and we have a property for division, but we do not have properties for addition or subtraction. So you cannot break up an addition problem or subtraction problem in the same way that you can multiplication or division. One more time, just to reiterate that, here's what I mean. You cannot say that the square root of 5 plus 11 is the same as the square root of 5 plus the square root of 11. What you can do is take the 5 and 11 and add them together. That's 16. And then the square root of 16 is equal to 4. Okay, so up here, bad. Down here, good. Make sure you have this written down very clearly. All right, a couple of more examples related to radicals, but now we're going to throw variables into the mix. All right, so I'm going to do a factor tree. I'm going to start with 2. Well, the only factor tree that comes down, or the only thing I can divide 2 by is 2. I'm going to also do a factor tree for my letters. So a squared means a times a, and I just have a single letter b. So I'm looking for that match 2 things that are alike, right? Well, I have 2 a's, so that means I can take an a out of the radical because it has a match, and then anything that it's remaining, I will put back inside the radical with a times sign between them. And then we're going to simplify. And I'm just going to write 2b because 2 times b is the same as 2b. And the a will still remain in the front. So that's how you would simplify example A. Let's try the next one. So 36, if I make a factor tree, is 6 times 6. And if you want to keep going, you could say 3 times 2 for each of these. You might have also not done any of this and recognized the square root of 36 is 6. So you could have just done that as well. And then here I have w to the 3rd. So that means I have 3 w's. So let's circle all the things that have matches. So I have a 3 that has a match. I have a 2 that has a match. And I have a W that has a match. The only thing that doesn't have a match is one of these W's. So one of these W's will go back inside the radical. And then all this stuff here that got taken out needs to be multiplied together. So this would simplify to 6W radical W. Okay? Remember that your division properties and your multiplication properties are a thing. So I'm going to start with applying those. And I'm going to separate this so that I can basically just look at one thing at a time. Okay? So now I'm going to go through and I'm going to make a factor tree. So I have x to the 5th. That's x times x times x times x times x. And I have a cube root, so I need 3 of the same thing to be able to remove it, which I do. So I have 3 x's, so I'll remove that. And I have 2 x's left over, right? 2 x's left over. So inside of my radical, I have 2 x's. And this was a cube root, so I need to bring that back over. And we're just going to simplify and call this the cube root of x times x, which is x squared. Okay? Oh, don't circle yet. Getting ahead of myself. So that's the numerator. The numerator would be x cube root of x squared. Okay, let's go to the denominator. Y to the 3rd is y times y times y. Since we're dealing with a cube root, we need 3 of the same thing to remove it, and we have that. So the denominator would simplify to just a y, and now we have our final answer. So you just take the top. So this looks kind of funny. I need to bring this up a little bit. There we go. You have your top, you have your bottom, put it back into a fraction, and you're done. The last one is a challenge problem. Remember that this is there's no property for addition and subtraction. So you cannot say that you can separate it like this. That's not a thing. Okay? This is not a thing. You can only separate things if they are products or quotients, multiplication or division. So this is a challenge problem because this doesn't appear to be multiplication or division. It appears to be plus. However, what you can do is both terms have a 4, so you can factor a 4 out of both terms. And when you do that, this creates a multiplication scenario because this is equivalent to 4 times a squared plus b squared. And now that you have a multiplication sign separating everything in your problem, you are then allowed to apply the multiplication property, like so. And remember, you can't do anything with the addition part over here. You can simplify your first radical because square root of 4 is equal to 2. So the best you could do to simplify this is make it 2 radical a squared plus b squared. Okay, one more topic to discuss is rationalizing the denominator. So it kind of is like one of those things where, you know how you're supposed to simplify fractions? Like 3/6 is, you know, a fraction, but we would rather you write it as 1/2 because that's the simplified version. This is kind of the same thing. So this is called rationalizing. Rationalizing is something that you would do if you get an answer that contains a radical in the bottom. Okay, it's like not a proper form, I guess, to have a radical in the denominator. So rationalizing is the process of moving the radical out of the denominator. So I'm going to show you how to do that because sometimes it is something you will have to do. So for example A, I'm going to break it up first using my division property, like so. Obviously, this does mean that we have a radical in the denominator. Okay, watch closely. all you have to do to get rid of the radical in the denominator is to multiply the denominator by itself. So I'm going to multiply by radical 3. Now, because I did that, I also have to multiply the top by the very same thing so that I'm keeping the problem balanced. Multiply by whatever the denominator is on the top and the bottom. Then you're going to go through and you're going to use your properties. So because this is a multiplication, I am allowed to multiply the inside numbers together and call that radical 15. Same thing on the bottom, that would simplify to radical 9. And right now it looks like we were unsuccessful because we still have a radical in the bottom. However, square root of 9 is equal to 3. You could make a factor tree if you'd prefer to do it that way, but square root of 9 is equal to 3. And since this simplifies to a whole number, not a radical, you are done. You may have to check and see if you can simplify radical 15. But you cannot in this problem. I'm just letting you know that it is possible that you may have work to do up here. But that's it. So let's look at a couple more. So B obviously does have a radical in the denominator. So to rationalize, we are going to multiply by that denominator on the top and the bottom. So we're multiplying the top and the bottom both by radical 5. Now on the top, the 10 is not inside of a radical, but the 5 is. So you cannot put them together and call it radical 50. Instead, you're going to write it with the 10, the 10 on the outside and the radical 5 on the inside. The 10's a whole number and the 5's inside a square root. They can't be combined together other than just like this. The two bottom numbers, however, are both inside of radicals, so you are allowed to multiply them together to get radical 25. Okay, now I'm going to focus on the bottom right now because square root of 25 is actually just 5. And from here, you're pretty much done. However, if you look at the whole numbers here, 10 and 5, those numbers are both divisible by 5. So we're actually going to take one additional step, and we're going to divide both of those whole numbers by 5, which will give you 2 radical 5 over 1. And then the final answer, completely simplified, is that it would just be the same as 2 radical 5. Okay, 2 more and we're done. For the next one, I'm going to show you actually 2 ways that you can simplify this. Option 1 is this. I see a radical in the denominator. I know that I'm not allowed to have radicals in the denominator, so I'm going to get rid of it. Okay, this is what we've just done on the last 2 examples. So we're going to simplify. On the top, I'm going to multiply the 2 square root numbers together. So 3 times 15 is 45. On the bottom, I'm going to multiply 15 times 15, which I believe is 225. And I'm going to simplify. So 2 radical 45. Actually, that's going to simplify. Let me do some work here. The bottom, square root of 225, is just 15. And then I need to go over to the side to do a factor tree for 45. Remember, you're looking for a match. You do have one, so it'd be 3 radical 5. So this radical here, square root of 45 is equal to 3 radical 5. You do have a 2 that was already in the front, so you're going to need to bring that over. And let me get this out of here. And you're going to simplify now. Okay, so you have on the top, technically, you just have a 6, a radical 5 over 15. And then you're going to look to see if anything will reduce, which on the top and the bottom, we can divide both of the whole numbers by 3. So we're going to do that. That's going to give us 2 radical 5 over 5. So that's one way to do it. Okay. Option 2. Option 2, what we could have done is we could have started by putting the radicals into a fraction all by themselves, like this, and then the fraction would have reduced because you can divide both things by 3. So watch how this works. 3 divided by 15 as a fraction becomes 1/5. And then what you can do is you can break it up and put the 1 in its own square root and the 5 in its own square root. And the square root of 1 is just 1. Whoops, I didn't mean 21. So 2 times 1 is what the top becomes, which is just a 2. And then you do still have a radical in the denominator. So at this point, you have to rationalize by multiplying by what you want to get rid of. But this would end up giving you 2 radical 5 over 20 radical 25. And radical 25 is just equal to 5. So there's your answer. Now, I feel like the top is a lot faster. The bottom has smaller numbers, still gets you to where you need to be. I guess it's kind of up to you, whatever you think makes most sense. Just choose one technique. All right, last one is not really rationalizing a denominator, just a quick review question. So we're going to start with 72. We're going to also work with a to the 5th, and we're going to work on breaking this thing down. So a to the 5th is a times a times a times a times a. 72, I believe 6 times 12 would work for that. And we're going to make a little factor tree for this one. So we're looking for, this is a cube root, we're looking for 3 things that match. So we do have 3 2s. And then we have 3 A's. And then we have a bunch of stuff left over. And remember, all the leftover stuff has to go back inside the radical because it doesn't have a match. So we have 2 3's that don't have a match, and we have 2 A's that don't have a match. So throw those back inside your cube root. There was still a 2 out here that we had to begin with, and that needs to be brought over as well. And it just gets combined with everything that's on the outside. So multiply your stuff on the outside and you get 4a. And then you have the cube root of multiply all this stuff and you get 9a squared. So that is your answer. That's it for the notes. Remember that you have to take the notes for a grade and submit them on Classroom. And you also have a Delta Math assignment over this lesson.